Okay, and we are back again in Series RL circuits. This time we are going to look at a short in a Series RL circuit. We're going to short around L2, and so you'll see that coming up on the screen here in just a second. So of course that's going to change the ohmic value of L2 from 4.15K to 0 ohms. We know a short sees no resistance for all intents and purposes, and so we see 0 ohms on L2. Now, no surprise there that our total ohmic value is going to change for our inductors. It was 10.93K, and now it is just the inductive reactance of L1, which is 6.78K. Alright, that is also going to change the total ohmic value of our circuit. So if you look, we did have 12.98K. Now we have only the combination of R1 and L1, which will make our impedance go down as well. So based on what we know of circuits, if the ohmic value of the circuit is going down, current must be going up. And we'll take a look at that. The current was 1.54 milliamps. And now with our new smaller ohmic value, we see a larger current of 2.05 milliamps. So that is indeed an increase. Based on what we know of circuits, we would expect R1 and L1 to follow current because neither of their ohmic values changed. And we would expect L2 to give us a voltage of 0 volts. So let's take a look at those numbers. We did have 10.78 volts on R1. That will change. It is going to go up because it has now a higher current, and we see that it has indeed gone up to 14.36 volts. And we see the same on L1. It was 10.44 volts, and now we take that same ohmic value by the larger current, and we see a larger voltage drop. Of course, L2 is going to go from 6.39 volts to 0 volts because we have a resistive value that is 0. So even though current has gone up, current multiplied by 0 is still going to give us 0, and we see essentially 0 across our second inductor. Now, we will still come up with applied voltage, and we would use our same formula that we have been using for that. We just put in our new numbers, so our larger voltage for both our resistive ohmic value and our inductor that's left in the circuit, and you use the formula and you come up with your 20 volts. So pretty simple. These you will find that these faults, there's no real difference a lot of times between the pure resistive circuits and the resistive inductive circuits or the resistive capacitive circuits. In fact, they are so similar that we are only going to do an open and a short for RL circuits, and we're going to skip those on the RC circuits. However, it is really useful to take a look at both when we get to having all three in the circuit, and we're going to get to that point as well, and then we'll look at what happens when you have multiple components beyond just the two in your circuit. Alright, and this wraps up a Series RL circuit short fault, and next we will be looking at arrows again.